Hello students, my name is Rakshit Sharma and I'm going to teach you a topic which is called as stationary waves. Now when we start this topic about stationary waves, in this very module we are going to study two things. The very first thing is how do these stationary waves get formed. The second thing that we are going to study is the definition of stationary waves. So let's start students the concept of stationary waves. And whenever I talk about these waves or any mechanical waves, how do I actually define a wave? Wave is an oscillatory disturbance which is traveling through any elastic medium. And that is the definition of mechanical waves. Now mechanical waves are of two types. Number one, which is called as progressive wave. Now as the name states, it is actually a progressive wave. A progressive wave is a wave which progresses or moves in a particular axis or in a given direction. So in this following diagram, we can see that there is a wave which is progressing in one direction, and such wave is a progressive wave. We move ahead the second type of wave, that is called as standing wave or stationary wave. And students, this standing wave or stationary wave is something that our chapter is all about. So, before moving ahead with our chapter stationary wave, we would like to revise what we have studied already about the progressive waves. There are certain properties of progressive waves. Let us discuss those properties. The number one being, it travels in a linear path, and that too continuously. As the name is progressive, it is going to be continuous traveling of this wave. Second, that it is periodic in time and space. That means it repeats itself in equal interval of time and space. Third, the particles vibrate with the same amplitude. Now particles are vibrating in this wave because it is a wave, it is a motion of oscillatory disturbance. The particles are going to vibrate with the same amplitude. And the next and the last very important point, that the phase continuously keeps on changing. So these are the points which are there for progressive wave. But then again, progressive waves are of two types. The first being transverse wave, and you can see the transverse wave diagram. In this wave, the wave is propagating towards right hand side, but the motion of particle is up and down. That means the direction of propagation and direction of motion of particles are mutually perpendicular to each other, and hence such kind of wave is called as the transverse wave. The next being the longitudinal wave, in which the direction of propagation of wave and the direction of motion of particles both are parallel to each other, and hence such type of wave is called as a longitudinal wave. But students, in order to study about the stationary wave, we must go ahead and learn a very important principle, that is principle of superposition of waves. According to this principle, when two waves reach at a point, at a single point, when they reach simultaneously, they produce a resultant disturbance. This disturbance, students, is a vector sum of individual waves. And how do I understand or how do I analyze it? I analyze it by drawing this diagram. You can see I have one wave. This wave is having the amplitude A1. I have another wave having the amplitude A2. When they come together at a point simultaneously, there is a resultant disturbance that is produced. Now this disturbance is a vector sum of individual waves, means the resultant amplitude will be given by A1 plus A2, where A1 and A2 are the amplitude of individual waves. So students, this is the principle of superposition of waves, and with the help of this, we studied interference between two waves. Also, in the previous chapter, with the help of this interference with the waves having equal amplitude and slight difference in frequencies, we studied a concept called as beats. Now whenever there were two waves which were having their interference happen with equal amplitude and slight difference in frequencies, they were called as beats. But in our chapter today, Now, two waves will be traveling along the same path, but not in the same direction. They will be in the opposite direction. They will have equal amplitude and equal frequency. And when they will interfere with each other, that means a phenomenon like this is going to happen. There is going to be a wave which will be called as incident wave. This incident wave will be striking the rigid boundary. On striking the rigid boundary, the phase reversal will take place and the wave will follow a reflected path like this. Now, when two waves traveling in the same path but in opposite direction, when these waves are interfering, there is a formation of loop or segment, as you can see. Now, this formation of loop and segment results in the formation of stationary waves. So students, let us define stationary wave. Stationary wave is defined as when two identical progressive wave both traveling along the same path but in opposite direction. As you can see in the animation, there is wave 1 which is traveling in one direction, wave 2 in the other direction, and we have the resultant wave. They interfere with each other, and by the principle of superposition of wave, the resultant wave which is obtained is in the form of loops, and this wave is called as the stationary wave. Students, here we need to remember that the two waves are identical and they are opposite in direction. In this animation we can see that the stationary waves is very slow, or this animation is very slow, but actually when it happens it is very fast, and thanks to the persistence of vision, the whole scenario appears like loop. So students, with the help of this module, we studied how do the stationary waves are formed and what is the definition of stationary waves. Thank you.